So now again, now I'm taking the circuit like RL circuit without source. Now what does that means without source? Can our circuit can work without source? Yes, we can see that this like if this is our circuit. Now let me take a different color. If we're having this switch and this switch was connected for very long time with this source, what will happen at the steady state of this condition, the current at this inductor will be V by R. So and after that what we'll do, we will make a switch over here. Now we will make the switch and we'll connect the switch from position 1 to position 2. Now our remaining circuit is not having any source, is not having any voltage source or not having any current source. So after even there is no circuit or there is no voltage source or there is no current source, whether the circuit will be having some current or voltage. Okay, let's observe it. Let's see that there will be or not. Yes, there will be, because as we know that inductor is having property of storage. So in the inductor there will be the storage energy. Energy has been stored in this inductor. Now what will happen after the switching? Now this inductor will behave as a current source. Will behave as a current source and it will provide the energy to the circuit. But as you know that there is a limitation of energy, there is a limited energy. Whatever the energy has been stored, that energy will be only used for rest of the circuit. So after some time you will observe that that the all energy has been lost through this resistor. So if there will be no resistor, yes, energy will be remain same. Energy will not be going to be lost. But in this case, since there is a resistor, so in this resistor this energy will get lost. So after some time we will observe that there will be no current and no voltage. But for this transient reason, up to what we have discussed, like up to this 5t, or you can say up to this 5 tau, there will be some energy, or you can say there will be some current, there will be some voltage. Now let's try to observe that what will be that voltage and what will be that current. Okay, so first of all, let's write the initial conditions. So can you tell me the initial conditions at at t is equal to 0? At t is equal to 0 minus, what will be the current? Quickly tell me. Am I audible? My question is audible or not? Yes, but why only two are giving me the answer? Yes, that's because we had already discussed this thing many times. So you should give me answer quickly, like V by R. And at t equal to 0 plus, since there is an inductor, current will not going to be changed, so we'll get V by R, same. And what will be the current at t equal to infinite? At t equal to infinite, quickly tell me what will be the current at t equal to infinite? 0. That's correct. So at t equal to infinite, we'll get 0. So these are the initial and final condition which we will be going to use to analyze the circuit. Okay, now I'm not going to go to that derivation. Now I will use the standard equation, and that standard equation is like I will use I t is equal to I at 0 minus I at infinite times e raised to minus t by tau plus I at infinite. Since I know the value of I0 and I infinite, I only require the value of tau, and the tau is given by, as we know that the tau is nothing but time constant, and this will be given by L by R. Okay, and if in the circuit there is like L means having different values of R and many values or many different values of L, so I will take the equivalent of them. So I will take L equivalent and R equivalent. So it will be having different values of R, like there is some more resistor, or there is some parallel resistor, or there is some other combination of resistor. So I will take the L equivalent across this inductor. Okay, and similarly, if there are suppose many inductors in parallel or in series combination of inductors are there, then in that case I will take the L equivalent. So we'll get time constant tau is equal to L equivalent divided by R equivalent. So for this circuit, our L equivalent is nothing but L and R equivalent is nothing but R. So I just need to put these values in this equation. So let's put these values in the equation. So what we'll get? We'll get IT. Yes, Neha, got it. So IT, since this is V by R, so let's put it V by R. And I infinite is 0. I infinite is 0. So let's put 0 over here. So you will get V by R e raised to minus T by tau. And tau is nothing but L by R. So you will get R by L times T. And I infinite is again 0. So you got this. You got it. This is the current. See, we can easily get the result. So it's very simple if you understand the concept. Okay, so once you got the current, you can easily find the voltage and you can easily find the voltage across resistor and voltage across inductor. So you can even draw the graph even. So you can observe from this, like at t equal to 0, your current is V by R. So you will get V by R. So this is your IT you can say, or IL. And with respect to time, so as your time increases, this value get diminished and you will get 0 at t equal to infinite. So you will get this as exponential decay of the equation. Okay, so this is a one kind of response. So you can easily get, similarly you can get VL. What will be the VR? You can say voltage across resistor. Voltage across resistor can be given by, just need to multiply with R. So if you will multiply with R, you will get V e raised to minus R by L times T. Yes, you need to IT into R. IT into R will be your this value. So you will get VL, and to get the value of VL, your VL is given by L di by dt. Since you are having I, you just need to differentiate this and you will get your VL. So let's find it. So you will get that like L into V by R, and if you take the differentiation of it, you will get multiplied with minus R by L, and then you will get e raised to minus L by R, minus R by L times T. So you will get this value. So here you will observe that R will cancel out and you will get this. So you will get like minus V times e raised to minus R by L times T. So again you can observe that if you will try to find out total voltage, this is always going to be, okay, we made a mistake over here. Okay, obviously it should be 0, that because there is no voltage source. So if we'll take for this circuit means if you are considering this circuit, the voltage across inductor and voltage across capacitor will always be 0. That VR plus VL must be 0 as your KVL, because there is no voltage supply. So you are getting the response exactly. Like if you'll add these two, you will get 0. And the response will be like, if you will consider in the same diagram, so you can observe that at suppose this is your V. Okay, let me rewrite it. So if let's consider that this is your VR, so this your VL will be given by this. This will be your VL. So this is your minus V and this is your plus V. So you can observe that anytime, if at any time you will observe that your total voltage is 0. So this is the overall response of your RL circuit without any source. So in this circuit you can observe that after switching you are not having any VR or any voltage source. Okay, so have you understand this? Have you got it? Okay, so is there is any doubt till now? No doubt? Okay, so if there is no doubt, let's go ahead with next slide. Okay, now we will take RC circuit with source. Okay, now to analyze your RC circuit, how will proceed? Let's start with our discussion again by using again same. We will start with like by taking the initial conditions and final conditions. So if we'll take the initial conditions again, let's consider that voltage across this, then your at time t equal to 0, the voltage across capacitor will be. Can you tell me what will be the value at time t equal to 0, Vishal? Because earlier it was not connected, so the voltage will be 0. So again at t is equal to 0, okay, plus it was at 0 minus. So again voltage is not going to be changed, but at time t equal to infinite, what will be voltage at t equal to infinite? Yes, now your voltage across capacitor is going to be V. So these are the initial and final conditions. Okay, so again now I'm not going to again derivate the equation. Now again what I will do, I will give you the standard equation, and the standard equation is like Vc at Vc at any time t will be given by Vc at 0 minus Vc at infinite times e raised to minus t by tau plus Vc at infinite. I hope you can understand that there is no major changes in this equation. The change means the equation is quite similar as we were having that previous equation. Is there is anyone having facing difficulty or having different like thinking like we are having exactly different equation? Is there is anyone? Okay, so I hope you can understand. And the only difference is that this tau, because now the circuit has been got changed. Now the tau of this equation is given by RC, or you can say C times R. Now the time constant is given by RC. The only difference or only change over here is this much. So if you understand that if we are having a circuit with a component R and C, then in that case your time constant will be R into C, or you can write this like tau is equal to, if there are multiple components, in that case you can write this as R equivalent times C equivalent. Okay, so now if we want to find this equation, and if we want to find the voltage across this capacitor, then from this equation you can easily write that Vc at t will be is equal to V at 0. V at 0 is 0, so we'll write it as 0. V at infinite is V, so we'll write it as V e raised to minus t by tau. T by tau, tau is your RC, so we'll put RC, and into e raised, oh sorry, plus V. So if we'll simplify this, then we can get that Vc at t will be is equal to V. If we'll take the common of V, then you will get 1 minus e raised to minus t by RC. Okay, so you can easily get the response. So this is your response. No, earlier you were correct, Srishti. So it is your V 1 minus e raised to t by RC. So this is the voltage across this capacitor. So if you got that voltage, now you can find any other relation. Like if you are having this voltage, you can even you can get the current, you can get other relations as well. Okay, so similarly we can have another circuit like this. Okay, so this is the exactly same circuit. So let me take different circuit. Now suppose we are having this circuit. Okay, so now you can tell me what will be the response of this circuit. What will be the VCT? Quickly you can tell me this. If we are having this circuit, can you tell me that what will be the response? This is your at, we have made a switch at t equal to 0. Okay, so can you tell me quickly what will be the VCT? VCT. Now I'm asking direct the response of the circuit. What will be VCT? Yes, the response will be like if we are talking about at t is equal to 0 minus, the response is going to be VC will be V, and at t equal to 0 plus, it is going to be again V, but at t equal to infinite, you will get VC is equal to V, oh sorry, 0. So these will be the initial and final condition. Then what will be the equation for this circuit, for this VCT? Okay, VCT is given by V times e raised to minus t by RC. Yes, I hope it's correct. Okay, is there is anyone having getting answer or not? How many of you got the answer? Quickly tell me the answer. I hope everyone can give me this answer. Yes. Okay. Okay, so you all are getting same result, and that is here V times e raised to minus t by RC. Okay, so now if we are having this result, so we can get other result as well. Okay, so can you tell me what will be your VRT without even solving the question, without even doing anything? Can you tell me what will be this VRT? Can you tell me what will be this VRT? Yes, that's right. Means we'll get only the differences that there will be minus, means because that sum should be equal to 0. So after this switching, the sum of voltages must be equal to 0. So we'll get minus V times E times T by RC. Okay, is there is anyone can tell me how will calculate I, as even in the previous question we didn't discuss about the current. How will get this IT? Anyone can tell me this, how will get this IT in this circuit after switching the circuit? What will be your IT? How we can get this IT? As in the first lecture of this transient analysis, I have told you that the current in the capacitor is given by C times dV by dt. Okay, so if you have got the voltage across this capacitor, you just need to differentiate this equation with respect to T and just multiply it by V. You will get your current. Okay, have you got it or not? So let's find it quickly. So this is going to be R time C times. If we'll take the differentiation, you will get minus 1 by RC e raised to minus T by RC. So this is going to be your current. Current is going to be minus 1 by R e raised to minus T by tau, or T by tau is nothing but RC. Okay, have you all got this? To get the current in this equation, and similar in the same way you can get the current in the previous question, in the previous